solve 2 sine squared theta plus cos squared theta is equal to 1. Now, in order to deal with this, you have to remember your trigonometric identities. And when you see a square and a sine and then a cos, or a square and a cos and then a sine, you're going to end up with a quadratic equation in sine. Alright? So we will change the sine squared theta to x at some point, or it could be, well, usually it's the case where when you change the sine squared theta from the identity, you're going to get a quadratic equation in cos. Alright? Because the identity that says sine squared theta plus cos squared theta equals 1, or is identical to 1. That is what you're going to use. So you're going to change the subject of that equation. Going to transpose it. Now, what I want you to do is bear those things in mind, pause the video, and work it out. As usual, whether or not I tell you, you should. Alright? Okay, so you're finished? Alright. So remember now, have the identity sine squared theta plus cos squared theta is identical to 1. Now what is sine squared theta? When you transpose this, right, sine squared theta would be 1 minus cos squared theta. So that is sine squared theta. Now this here says 2 sine squared theta. But the sine squared theta is the same as 1 minus cos squared theta. So you're going to say 2 times 1 minus cos squared theta plus this part now plus cos squared theta equals 1. Now, you can see, oh, plus cos theta, not cos squared theta. Oh, where did I get the square part from? Alright, you can see that there is a cos square and there's a cos. If you make cos squared theta becomes x, then you have an x squared and an x. So you solve a quadratic equation in x and then substitute back the cos squared, the cos theta for x later on. So this is going to be multiply the brackets, 2 minus 2 cos squared theta plus cos squared theta is equal to 1. Now, negative 2 cos squared theta plus cos squared theta. Same thing as plus 1 cos squared theta. Negative 2 of anything plus 1 of that thing is negative 1 of it. So I have 2 minus cos squared theta. Oh, I write back cos square again. Why you keep writing cos square here? Alright. That's why I had said I wrote cos square on it and then forgot that it should be cos. That's why I said negative 2 plus 1 is negative 1, but it's not going to be added. You can't add cos square and cos. So that was my mistake. Alright, plus cos theta is equal to 1. Alright. Now you want to write this in the form ax squared plus bx plus c equals 0. So suppose you say negative cos squared theta plus cos theta. Keep everything on the left. They say plus 2, and then you subtract 1 minus 1 equals 0. Now, you're going to have negative cos square theta plus cos, again I wrote back the square, keep writing square, plus cos theta. 2 minus 1 is 1, plus 1 equals 0. Okay, good. Now, of course, you could very well, oh, there's a 2 here. I left off the 2. Alright, the 2 remains there. Yeah. Now, you could very well work with the negative 2 and so on, but could change the first term to positive, make it look less confusing. But before you do that, suppose you let cos theta be equal to x, and what you get is negative 2x squared. See that? Plus x plus 1 equals 0. Now, let us change the first part. Right? Let us change the first part to from negative. So multiply it through it by a negative 1, and you get 2x squared minus x minus 1 equals 0. Right? You don't necessarily have to do that, but I personally find it less confusing when I have the first part, the x squared part positive. Alright, so here, how could you work this out now? You could use factorization or trifactorization. Could it be factorized? 2 times negative 1 is negative 2. So you have negative 2. So 2 times negative 1 is equal to negative 2. That's A times C. Two numbers that multiply to give negative 2 and add to give negative 1 would be what? That would be negative 2 and 1. Negative 2 plus 1 is negative 1. Negative 2 times negative 1 is negative 1, right? So you could use those and your factorization, right? But let us try it out using not completing this, yeah, completing the square, right? Let's try that out. It's good practice to try your completing the square, because it can be used to solve any quadratic equation. You're going to have half of everything first, because you want a 1x squared, not a 2x squared. So you half everything. Half of 2 is 1. So you have x squared minus half x minus half equals 0. Alright. Now, remember, you're going to have this thing in the form x plus h squared is the same as x squared plus 2hx plus h squared. That's a complete square. So you have x squared minus half x, I leave a space, minus a half equals 0. What you're going to put here, right here, is same thing here. The coefficient of x is 2h. Half of 2h is equal to h. h squared is this. So you put half the coefficient of x and you squared everything, right? So you say plus the coefficient of x is negative half. Now, half of the coefficient of x is going to be negative a quarter. So negative a quarter, and you square it. Alright? So you added half of negative half is negative a quarter, and then negative a quarter square is what you add. Now, since you added negative a quarter square, and you're keeping on the same side, what you need to do is compensate by taking it back off. So you minus negative a quarter squared. Alright, you see this part? You have x squared plus half x, which is like 2hx, plus half of negative half squared. So it's half of 2h squared. So this can be written as x plus h squared. So in this case, h would be negative a quarter. So you have x plus negative a quarter all squared. Right? Just like what you have here. And then you work this part out. Minus a half minus negative a quarter squared is 1/16 equals 0. Alright. This can be written as x minus a quarter squared. Right? If we did factorization, will be finished already. At least that part, but we want to practice our completing the square. Minus. Now, what is negative half minus 1/16? You could use common denominators and say 8 2s 16, 8 1 8 up top, minus 1/16 equals 0. So x minus a quarter squared. Now, if you have negative 8 of anything minus 1 of that same thing, you get negative 9 of it. It's minus 9/16 equals 0. You could now write this as x minus a quarter squared is equal to 9/16. Then square root both sides, and you get negative x minus a quarter. Oh boy. X minus a quarter is equal to positive and negative. Square root of 9/16, which is 3. Square root of 9 is 3 over square root of 16 is 4. So you can say now that x is equal to, add a quarter to both sides, you get a quarter plus or minus 3/4. So therefore, x is equal to a quarter plus 3/4 is 4/4, which is 1. And x is equal to 1/4 minus 3/4 is negative 2/4, which is negative a half. Alright. So you have your x's. What was x again? X was cos theta. So cos theta is equal to 1, and cos theta is equal to negative half. Alright. Now, here, you are going to find out what these really are. Alright? Now, there will be, well, did the question say between 0 and 360? Well, it didn't, but let us find it between 0 and 360 degrees. Alright? We find it between 0 degrees and 360 degrees. When cos theta is 1, then you find cos inverse 1. There's a calculator. Alright? So, just to make sure that this is in degree, although I don't know how to put this in radian, but sine 30 is half. Just for reassurance. Alright. So cos inverse of 1 equals, so theta is 0. One angle here. You get one of the angles, 0. So call it theta 1 equal cos inverse of 1 equals 0. Alright? Now, if you draw your unit circle, have your 4 quadrants. Cos is adjacent over hypotenuse. You have 0, 90 degree, 180 degrees, 270 degrees, and back here is 360 degrees. Now, so let me just put on the degree part now. Alright. Now, if cos theta is 0 degree, then, is cos theta is 1. So cos is adjacent over hypotenuse. This is the hypotenuse and this is also the adjacent. So 1 over 1 is 1. Alright? That's why cos 0 is 1. It also happens here. Oh, no. If you go over here, the adjacent will be negative. Right? So, if you consider doing it, finding the angle between 0 and 360 degrees, it happens at 0 and it also happens at 360. So the second angle, theta 2, is equal to 360 degrees. So we have two angles already from the cos theta equals 1. Now what about the cos theta is negative half? Now call this theta 3 is equal to cos inverse of negative half. Now what would be cos inverse of negative half? We have cos inverse, open bracket, negative 0.5, close bracket, equal 120 degrees. Now, that's 120 degrees. Now, that's from the fact that when you have negative half, the adjacent, which is a negative over the hypotenuse. Now here, adjacent over hypotenuse. If you consider this, then the adjacent would be this length and the hypotenuse would be here, right? Now, this would be the angle, 120 degrees, right? Now, where else does this happen? If you consider the next time when you have a negative adjacent and, well, the hypotenuse is always positive, it would have to be in the in the second or third quadrant, because this adjacent is negative and you want a negative half. This adjacent here is positive, so it can't come over here. This adjacent is negative. So the negative, that negative adjacent over this hypotenuse is the next time it happens that you have the cos theta is negative half. Now, in this case, what will that angle be? If you find out what this small angle is, alright, what should we call it now? Call it alpha. Now remember, the adjacent, right, it would be like this triangle here. This is alpha, 90 degrees. Adjacent over hypotenuse is half. So cos inverse of half would be what? If we find the cos inverse of 0.5, let's change this from negative to positive 0.5, and we get 60 degrees. So that little angle in there would be 60 degrees. Now this would also be 60. So if you come right around and come here, that's 180. And then you add 60 more. Now 180 plus 60 would be 240. So the fourth angle, theta 4, is equal to 240 degrees. Alright? So there are actually 4 angles that you would have found. Right? Now, ensure that you understand everything in the working, and the part you don't understand, make sure you review. And when you're done reviewing, try this question without looking back at the notes, without looking back at the video. I'll see you in the next video.